Hi, in this video we will review trigonometric identities, the ones that we will use in this course and we will need for this course. Let me start with the first one, the basically easy one and very fundamental one, which is well, for any theta, for any angle theta, what we have is a sine of theta. If you find it, then square it, and then you find cosine of theta, square it. You add these two, you will get 1. No matter what is theta, this is going to be equal to 1 always. Well, this is an easy result of Pythagorean theorem. And the reason for that, well, I can show you at least for the acute one right away here. This is theta, this is right angle, then this is opposite, this is adjacent, this is hypotenuse. Well, then a sine of theta, by definition, we know that is opposite over hypotenuse. If you square it, this will be squared. You add this to cosine theta is adjacent over hypotenuse. And if you square that, this will be squared. And well, square both one, they have common denominator h squared, and you'll say o squared plus a squared. But remember, this is a right triangle, so Pythagorean theorem says that two sides a squared plus o squared will give us h squared. And this cancels that, this is equal to 1. And well, that is why this is true, and this is one of the important one, and you have to be able to use this. This is absolutely the easiest identity we have for trigonometric functions. Let's do one example of this one. Example maybe 2. Prove the identities. Yes. The first one is 1 plus tan squared theta is always equal to secant squared theta. And then the second one is if you have cosine theta over 1 minus sine theta, this will give us secant theta plus tan theta. Okay, let's prove these ones. You see how we are using that identity. Well, look at the left hand side of this equality. This is 1 plus tan squared. I just start from the left hand side. Well, we know that tan is sine theta over cosine theta, and we have a square of that there. Well, then this will give us sine squared theta over cosine squared theta. This we can find common denominator, and now you see that the numerator is sine squared plus cosine squared. The identity says that sine squared plus cosine squared is always equal to 1, so we have 1 over cosine squared theta. And cosine squared, 1 over cosine squared, we can write it as 1 over cosine theta, then squared, which is same thing as secant theta squared. And that's what we have on the right hand side. For this one, it might be a little bit trickier, because when you write this cosine theta, 1 minus sine theta, when you look at this one, well, we don't see any sine squared or cosine squared. But what we can do is that we can multiply both of the numerator and denominator by 1 plus sine theta. And the reason we are doing this, you see in the denominator, we are multiplying 1 minus something, which happens to be sine, to 1 plus the same thing. In the numerator, we have cosine theta, 1 plus sine theta. So 1 minus sine times 1 plus sine. This is the famous a minus b times a plus b. So it will give us 1 minus sine squared and cosine theta 1 plus sine theta in the numerator. Very nice. 1 minus sine squared is equal to cosine squared. So let me just put it here. Cosine squared is 1 minus sine squared theta. Why? Because, well, I'm just taking the sine squared from left hand side to the right hand side of the identity we had at the beginning. So this will give us cosine theta 1 plus sine theta over cosine squared theta. And then this cancels with that. We can write 1 plus sine theta in numerator over cosine theta. Well, we can separate the denominators, and as you can see, this will give us 1 over cosine is secant theta, and sine over cosine is tan theta. And this is right hand side. We started from left hand side, and using some steps we got to the right hand side. That means that we proved the identity. So as you can see, you have to be able to do these kind of steps, combine very easy facts, identity that we set up there, with very easy algebraic manipulations and prove different identities. Okay, so that's the first identity, but another very important identity, this is called addition formula. As the name suggests, it's about sums of two angles. So if you have sine of x and y, this can be proven to be equal to sine x cosine y plus sine y cosine x. So in other words, sine of x plus y, we can write it in terms of sine and cosine of x and y. And there is a formula for cosine. When you have this, then this is equal to cosine x cosine y minus sine x sine y. You have to see the differences here, what is happening. These are completely different things for sine and cosine. And well, with very small work, one can also prove that there are formulas for subtraction. That's called subtraction formula. But when you find x minus y, the middle sign, and in the case of cosine x minus y, the middle sign changes. That's the only difference we have. So let me write with this that this is subtraction formula also. Subtraction formula is very easy fact of from addition formula, and the fact that sine and cosine are oops, I can take another box. Okay, so this is the second important formula. Well, the results of this addition formula most of the times are important, more important than the formula itself. For example, if, so let me write this as 2, 1. If x and y are the same thing, what will happen? So here I will have sine of x plus x equals to sine x cosine x plus sine y. Oh, sorry, there's no y. Everywhere you see y, you plug in x, cosine x. As a result, what you will get is sine, well, let me write it here. Sine of 2x is equal to, these terms are exactly the same thing, and we have two of them added, so this will be 2 sine x cosine x. And for the cosine, is cosine of x plus x equals to cosine of x times cosine of x minus sine of x sine of x. As a result, we get cosine of 2x equals to, well, cosine times cosine is cosine squared x, and sine squared x, but they have minus sign in between. These formulas are important formulas, and they have a name. They are called double angle formulas. So let me write it here, double angle formula. Because they give the sine of 2x and cosine of 2x, double angle. Well, the second double angle, if you take, so let me do this one too. So let's take the second one. Cosine 2x is equal to cosine squared x minus sine squared x. Well, we can easily do some work that, well, we know from the first identity that cosine squared x is 1 minus sine squared x, yes. I can plug it in here, so we get cosine 2x equals to 1 minus sine squared x, and there's another minus sine squared there, and as a result what we get is cosine of 2x equals to 1 minus 2 sine squared x. Well, if someone does this work, instead of writing cosine squared equals to 1 minus sine squared, we can also do, sub in sine squared x equals to 1 minus cosine squared x. And then as a result of that, what we will get is, this is another version of double angle. So cosine 2x is equal to, this time, 2 cosine squared x plus or minus 1. Yes, instead of sine square, we put 1 minus. So that's why. So these two formulas are different forms of a double angle. Let me just make my own box here. But these formulas can be used in a different way. We can solve this one. Let me just show the first one. Using this cosine 2x 1 minus 2 sine squared x. I can take this one to the other side. Oh, I can write negative 2 sine squared x equals to cosine 2x minus 1, and then divide by negative 2. So sine squared x is going to be 1 minus cosine 2x over 2. I divided by negative 2, so that's why I switched this thing. And this formula what it says that I can write sine of x in terms of cosine 2x. This, using this formula, we can basically find sine of half angle. That's why this is another version. It's called half angle formula. Well, half angle formula here, there's another version of that which says that cosine squared x is also equal to 1, this time, plus cosine 2x over 2. So that is half angle. So as you can see, I can just play with these things, but what I want you to understand is that you have to be able to do these steps, and you have to at least understand these two and the original one that we had up there. Well, let me finish a video with two small examples. One would be example 1. Show that sine theta plus cosine theta squared is equal to 1 plus sine 2 theta. Okay, to prove this one, I will just start from, again, left hand side. This is sine theta plus cosine theta squared equals to sine squared theta plus 2 sine theta cosine theta plus cosine squared theta. Remember, the identity a plus b squared is a squared plus 2ab plus b squared. And then I can rearrange these things. I can write sine squared theta plus cosine squared theta plus 2 sine theta cosine theta. Sine squared plus cosine squared is always equal to 1, and 2 sine theta cosine theta, this is double angle formula. So let me just show you here. 2 sine x cosine x is equal to sine 2x, and that gives me sine of 2 theta, and this is right hand side. So we had proven this guy to be true. Well, sometimes these identities, you can use these ones to solve equations. For example, find all x's in 0 to pi such that 2 cosine x plus sine 2x is equal to 0. Okay, so when you're trying to solve the equations which have trig functions, one of the tricks that always help is that try to put sine and cosine in the same footage. Here is sine of cosine of x, but here is sine of 2x. So let's just bring it to sine x, but we know that sine of 2x is equal to 2 sine x cosine x. Well, I can then factor out 2 cosine x, and this gives me 1 plus sine x equals to 0. When you have two expressions equal to 0, then either this guy is equal to 0 or this guy is equal to 0. This tells me that cosine of x is equal to 0. And in the interval 0 and 2 pi, we actually have two of those ones. One is pi over 2, and the other one is 3 pi over 2. From this one, we get sine x equals to -1. What is the angle whose sine is -1? Well, there is 1 in the interval 0 to 2 pi. This is 3 pi over 2. And that's the only one which gives us sine -1. And well, you see these ones, so then as a result, x can be either pi over 2 or 3 pi over 2. The summary is that you have to know the basic identities and how to use those ones and argue and prove more identities and more identities. Keep in mind the basic identity that we had here, the double angle and half angle, because these are the main ones that we will